Hi, I am Shayan Sarkar. I will present SGAligner, the first method for aligning static and temporal 3D scenes using scene graphs. This is a joint work with Andrej Miksik, Mark Polifes, Daniel Barat, and Ido Armeni. With their increased use in solving downstream tasks, can we leverage and recycle 3D scene graphs for creating 3D maps of environments? We focus on the fundamental problem of aligning pairs of 3D scene graphs whose overlap can range from zero to partial and can contain arbitrary changes. Typically, alignment procedures use techniques like local feature matching or global ICP, which are associated with issues such as inaccurate initialization and limited robustness in handling point cloud variations. However, recently 3D scene graphs have emerged as a structured and rich way to represent the world. These representations are easily scalable, updatable, as well as lighter weight and more privacy aware. Operating on scene graphs is fast and robust to real-world scenarios. We provide an overview of our framework. Given two 3D scene graphs with partial overlap, we create four unimodal embeddings to encode object, structure, attribute, and relationship information. The object encoder receives an input, individual object instances in the form of a point cloud. 3D scene graphs contain relationship information which we leverage in the form of a structure graph to encode the layout. We also model the attributes and corresponding relationships per object in two separate meta-embeddings. The above unimodal embeddings interact to create a joint embedding space, and we use the similarity in this space to create an aligned 3D scene graph. We further demonstrate the use of the alignment in 3D point cloud registration, 3D point cloud mosaicing, and finding non-overlapping scenes. In the absence of a dataset for these tasks, we generate one using state-of-the-art datasets 3RScan, which contain RGBD frames and the reconstructed point clouds, and 3D SSG, which contains the corresponding 3D scene graphs. Given a point cloud, we create multiple subscenes as shown in the left and right columns. To imitate a realistic setting, we form subscenes by extracting sets of consecutive frames and then reconstructing the point clouds with the potential for 3D spatial overlap between them. We first evaluate how our method performs on node alignment. SGAligner provides accurate matches despite the noise in the input when using predicted and not ground truth scene graphs. We also evaluate how well two scene graphs can be aligned given the predicted node matching. Scene graph alignment recall for the top two matches is approximately the same for both ground truth and predicted data, which further highlights our alignment robustness. We approach 3D point cloud registration by leveraging scene graph alignment results and collecting the point correspondences across all matched entities to feed into a ransack-like estimator. Such an approach is robust across ground truth or predicted data. More importantly, it performs better than standard registration methods even on point clouds with low overlap. Given input 3D scene graphs on the left, we showcase the output of SGAligner for alignment in the middle and registration on the right. In practical applications, we do not always know if two scenes are overlapping or not. While standard registration approaches compute matchability score, they typically train and test only on overlapping scenes. We showcase registration failure with state-of-the-art methods on non-overlapping point clouds. On the contrary, our alignment score is 0 in such cases, thus removing the need for registration. Our approach runs 3 times faster than state-of-the-art methods and leads to comparative performance while being able to identify overlapping pairs more correctly. We further demonstrate the potential of SGAligner on 3D point cloud mosaicing, that is, reconstructing the 3D scene by observing parts of the scene. Please note that there is no guarantee that all partial clouds overlap with the one chosen as origin. Although this falls outside the scope of this paper, our approach still performs comparably to geometric registration methods on the aspect of accuracy and completeness of the resulting reconstruction. Thank you for listening. We are glad to welcome you to our poster session on Friday, October 6, 2:30 p.m. to 4:30 p.m. at ICCV.